So, hey trig folks, come a little closer. Come on. Yeah, this is me. I'm your instructor. I'm a real person. I just wanted you to know that and remember that if you ever have any questions on any of these assignments or any of the notes, you come and see me or send me an email or call me or have a conference via CCC Confer. Okay? Lesson 1.4 is trigonometric functions of any angle. An angle is formed by rotating a ray OA about the endpoint O called the vertex. So it forms a new ray OB. Now, the reason why this section is called trigonometric functions of any angle is because before in 1.2 we were dealing with trigonometric functions of an acute angle. This includes any angle. We can have negative degrees like negative 270 degrees. We can deal with angles greater than 360, 390 degrees. We can deal with 195 degrees and so on. So basically what you do is you always start, this is called the initial side. This is going to be the x-axis. That's a little preview. And this is ray OA. Then you extend your ray and it becomes the terminal side, which is OB. So you're going to hear me use these terms, the terminal side and the initial side in your ray. Keep in mind that when you go in the counterclockwise direction, your degrees are going to be positive. When you go in the clockwise direction, your degrees are actually going to be negative. Full angle, we start at OA. One full revolution is 360 degrees. Okay? If you went the reverse of that, start at OA, ray OA, and did a revolution of 360 degrees, that would be negative 360 degrees. So this is from the textbook, but if you have an angle that rotates from the initial side 390 degrees, notice that an angle that coincides with the 390 degree angle is also a 30 degree angle, because if you think about it, you're going 360 degrees, that brings you back to your initial side plus 30 degrees more, and that's equal to 390 degrees. But it is important to also remember that an angle that coincides with that is also 30 degrees. So now what we're going to do is we're going to take that angle, remember that ray OA, so here it is, and we're going to put it on the Cartesian coordinate plane. So this is actually the x-axis, if you can see that. This was your center O, and we're going to take the initial side and we're going to rotate it. This is the terminal side of your ray. This would be the OB. And we're going to put it in the XY plane. And this right here, another way to think about this, remember that it always is an XY pair, so you have X, Y, and since X is greater than 0, that means that X is positive and Y is positive. Just for a quick review, remember you list the X first, you go over in the X direction and then up in the Y direction. Note here that X is negative and Y is positive, and that's what it says right here. In quadrant 3, X is negative and Y is negative, and in quadrant 4, X is positive, but Y is negative. So these trig ratios might look familiar, and they are, but now we're extending this, like I said, to any trigonometric function of any angle. So we were just dealing with right triangles and acute angles before. Now we can deal with any angle we want to, be it negative, positive, greater than 360 degrees, anything like that. So we're going to let theta, this is theta, be any angle theta as in a standard position if its initial side is the positive x-axis. So that's where we're starting right here. We're starting on the x-axis right here, and its vertex is 0, 0. So remember the origin is 0, 0. Okay, so the terminal side, once again, is we're going to let xy, which is right here, be the point on the terminal side. And as long as the length from here to here is greater than 0, that's your radius. It stands for r. then you can set up these trig ratios. Now let me explain a little bit about this. R actually is equal to, and let me explain why. If I drop this down, an altitude down, I know then from the origin I'm going over negative x units, and I'm going over up y units, if we're in quadrant 2, that is. Okay, so the radius, I could say, because this is a right triangle, going back to right triangle trigonometry, length x squared, I could do the negative if I wanted to. Doesn't matter though, it'll be positive, plus y squared is equal to the radius squared. So I can say then that the length r is going to equal the square root of x squared plus y squared. And that will always be the case. So think about these ratios, and we'll talk about it, how they connect to the right triangle soon. But if you're dealing with anything, you know that the sine of theta is y over r, the cosine of theta is x over r, and the tangent of theta is y over x. This is something that you can choose to memorize, or I'll show you how it connects to a right triangle. Maybe you can see it right now, but I'll get to that in a second. Sine theta in when we extend this, it always deals with the y's. Okay, cosine theta always deals with the x's, and tangent theta is always the y's over the x's. So if you can just remember that, that'll help you. Meaning the y coordinate, okay, and the x coordinate here for cosine theta. All right, and then remember cosecant theta is just the reciprocal of sine theta, so it's r over y. Cosine theta is the reciprocal of secant theta, which is r over x. Tangent theta is the reciprocal of cotangent theta, which is x over y. We'll do some examples soon and it'll all make sense shortly. So notice that these ratios are the same if we're dealing with, once again, an acute angle here. So in quadrant 1, we have an acute angle. We'll call this angle theta. If you drop a perpendicular down, this becomes your right triangle. Here's the point xy. So that means I'm going over to the right x units and I'm going up y units. If this is your reference angle theta, then I can say that the sine of theta, remember what we would do? We'd say it's the opposite side, so over hypotenuse. Okay, well, what is that? Opposite side is equal to y. Hypotenuse is r. We're calling this length r, the hypotenuse. Okay, so that's the same idea. Cosine of theta is equal to ca. That's adjacent, so that's adjacent side over hypotenuse. So if you look at what adjacent side is equal to, that's x over r. And then tangent of theta is opposite over adjacent. And that's where we get our y over x. And remember that cosecant theta is just the reciprocal, so that's the r over y. Secant theta is equal to the reciprocal of cosine theta, so that's r over x, and cotangent theta is equal to the reciprocal of tangent theta, which is x over y. So if you ever get stuck, you can always go and work with an acute angle in the first quadrant and set up your ratios from there. So in trigonometry, you have to get really familiar with dealing with the 360 degrees and all the things that are divisible by that. So we're breaking up 360 degrees quite often in this class. So remember, we start at 0 degrees and then our rotation. I just wanted to point out this nice diagram. Anywhere from 0 to 90 degrees is quadrant 1. 90 to 180 degrees is quadrant 2. And an angle can be 180 degrees, just so you know. So we can end up terminal side right here at xy. Okay, and we'll get to that in a little bit. But actually, yeah, we'll do that in a second. Just wanted to point out that 180 to 270 degrees here, 270 to 360 degrees here. When dealing with angles such as 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, because remember this is also 360 degrees, we can set up our trig ratios, and it's kind of fun that we can pick any point on the x-axis. So choose the easiest point. We choose 1. So this length right here is a length of 1. There's no up or down, so the y value is 0. So if I'm asked to find what the cosine of 0 degrees is, I can say that that is, remember, it is x over r. So we have x over r. Now another thing to remember is that r is the distance from the origin. So in this case, what is the distance from the origin at this point, 1, 0? It's 1 unit as well. Okay? So if I say that cosine of 0 degrees, well, I know that x is equal to 1 and r is equal to 1. So then cosine of 0 degrees is equal to 1. If we set up the sine of 0 degrees, well, that's equal to, in this case, y is equal to 0, r is equal to 1 once again. So we have 0 over 1, and if you simplify that, that's equal to 0. Well, what about tangent? Tangent of 0 degrees is equal to y over x, 0 over 1, which is equal to 0. If we think about the reciprocal of secant, or of cosine, which is secant of 0 degrees, we can say that the reciprocal of that is 1. If we did the reciprocal of cosecant of 0, this would be undefined. And remember, if you have, which is 1 over 0, that's not possible, okay? The tangent, once again, would also be undefined, or the cotangent, excuse me, of 0 is undefined. Okay, so we're going to try that with one more angle, and then I want you guys to try the other angles. So let's do 0, -1, and 270 degrees. So in this case, do you see that x equals 0, y equals -1, and the distance from the origin is 1 unit, r equals 1, because this distance from 0, 0 out to here is 1. So if I set up and I write the cosine of 270 degrees here, that is x. Remember, cosine goes with x, so it's 0 over 1, which is equal to 0. The sine of 270 degrees is equal to, what is that, y, so that's -1 over 1, which is -1. Interesting, we're getting a negative for sine. And then the tangent of 270 degrees is equal to -1 over 0. That's undefined. So if we do the reciprocals of that, secant would be undefined of 270, undefined, excuse me, I'm getting sloppy here. And this would also equal -1, so that's the cosecant of 270 is equal to -1, and this right here, the cotangent of 270 is actually equal to 0. So a couple of other things I want to show you. If this is 270 degrees all the way around from here to here, what would be an angle that's equivalent to that? You could start here, and I could go in the clockwise direction, which is negative. So this angle, -90 degrees, is also equivalent to the tangent. So if I said, for instance, the sine of -90, that's also equal to -1. Okay, so let's start practicing. Numbers 1 through 10, you're just supposed to state which quadrant or on which axis the given angle lies. So -127 degrees. Remember, here's the origin O. We start on the x-axis, okay? You can even draw the x and the y-axis. So we'll just do that. Here's the x, here's the y-axis. Get a different color here. Okay, so I'm starting here, and I'm going in a clockwise direction. Now I know that I've got to go beyond 90 degrees. That would be here. That would be -90 degrees. And I'm going to end up somewhere here, right? I know it's not 180. That would be all the way across. This is negative 180 right here. So it's somewhere in quadrant. This is 1, quadrant 2. So this is quadrant 3. So the answer is quadrant, we could say, 3. Okay, so with negative 313 degrees, now if I start here, let me change on the x-axis. Right here, this is my initial side. I'm going to go around 180 degrees, and then I'm going to go up to 300. Let's see. So this is 180 degrees. This is, I know, or negative 180. This right here, if I'm going in this direction, is negative 270 degrees, right? So I'm going to end up, and all the way around would be 360 degrees if I end up here. So it's between negative 270 and negative 360 degrees. So that puts me in quadrant 1. So this is quadrant 1. Now, 2009, how many rotations is that, and where does that land me? So let's start here. It's positive, so we're going to go counterclockwise. If you do 2009 divided by 360, just to see how many times it goes around, it ends up being like 5.58 and some change. So it means I'm going to go around. I'm going to start at here so I can make it around. Here's one time around. Here's another time. That's 2. So we have 1, 2, 3. This is pretty, huh? 4. One more. 5 and some change. So then in my calculator, I just did 5 times 360. That gave me 1,800. So I have 2009 minus 1,800. That's the even amount of revolutions. So the 1,800, I'm right here. That equals 209 degrees. So I have 209 degrees left. That means I'm going to go through the first quadrant, the second quadrant. See, because this would be 180 more degrees, and now 270 degrees would be down here. So I'm going to stop in quadrant 3. Whew, that was a workout. So 2009 degrees would land you in quadrant 3. So this is a table from your book, but I don't want you to memorize it. I just want you to make sense of it. Notice that in the first quadrant, all of the ratios, sine, cosine, tangent, cosecant, secant, and cotangent, are all positive. And think about it. X is positive, so whatever ratio, y is positive, and the radius, or r, I keep saying radius, I'll get to that and why it makes sense in a little bit, but just r, the distance from the origin, think of that now, is positive. So all of the ratios are going to be positive. In this second quadrant, quadrant 2, sine is positive. Well, if you think about it, some point here, it's an xy point, right? X is going to be a negative value, remember, and y is a positive value. So the reason that sine is positive is because it's y over r. Y is a positive value. R is always positive. For cosine, think about why cosine would be negative. Because you have x over r for cosine, associates with the x. X is negative, remember? So you have a negative over a positive number, which gives you a negative ratio. Okay, now interesting thing in quadrant 3, see how tangent is positive? Well, think about what tangent is. Tangent is y over x. So that is in here, remember this point's negative and a negative. Negative x value, negative y value. So you have a negative over a negative, which makes a positive outcome. Same with cotangent there. So, and with all of these, sine, cosine, cosecant, and secant, they're negative because you have a negative y value over r and a negative x value over r. And similar case for quadrant 4. So something to look out for, and that will help you with numbers 11 through 16. Reference angle. This is a definition that will help you in the future, so be sure to understand it. It's an acute angle of theta formed by the terminal side of theta and the positive or negative x-axis. So let me tell you what I'm talking about. For number 17 through 21, this will help you. So it says find the reference angle. So for number 18, you have an angle of 63 degrees. So what I do is I draw my angle 63 degrees. That's theta. The thing is that theta is already an acute angle. But just to show you, you could drop what's a perpendicular, the angle that's formed between the x-axis, and that's the definition of a reference angle, and this terminal side, and it's 63 degrees, and that's the acute angle. So it's the same. Okay, let's do one that's more interesting, number 20. So what we're going to do is, once again, 696. You're going all the way around 360 degrees, okay, plus some change. So if you just, in your calculator, I mean, I'm just doing this simple 696 minus 360 degrees. That tells me that I have left 336 degrees, okay? So I'm going to go around again, and that's going to land me in quadrant 4. And the way that I got this angle, so here's the terminal side, this ray, right? And this is, if I say this is theta, so theta is equal to 336 degrees. So to find the reference angle, I'm going to basically measure the angle between the x-axis. So this is the positive x-axis. I'm going to use the positive x-axis, and the terminal side. So this angle right here. And if basically you go 360 minus 336, that'll give you that angle, which is 24 degrees. So this angle is 24 degrees. This is my acute angle between 0 and 90 degrees. That's going to be my reference angle. Let me show you one more example so that we can drop a perpendicular. So I'm just going to make it up, and I'm going to say, okay, how about 170 degrees? What's the reference angle? So 170 degrees lands me right here. Notice I chose a nice number. Here's my ray. Sorry, graph is not to scale. And if we think about the x-axis, I'm going to use the negative x-axis right here, and this ray, and what is the degree? Well, this is 180 degrees minus 170 degrees, so this reference angle is going to be 10 degrees. For the last set of exercises, I'm just going to show you a bunch of examples. You guys have to do the odds, but let me demonstrate this. Let's start with, actually, I know this isn't a problem that you have to do, but I'm going to do it because it has a negative value. So I want to show you and work with a negative. So we have the cosine of theta equals negative 1/2. I think that's hard to read, so let's do some green. So with this being said, cosine of theta equaling negative 1/2. Well, remember, negative 1/2, the ratio for cosine theta is x over r. So that's telling me that x is equal to negative 1 and r is equal to 2. If we think about where that theta, that reference angle might lie, where is, what quadrant deals with negative 1? Well, that's quadrant 2 and quadrant 3. Okay, so we have two options here. So the angle could be up here, so it would be at this point, negative 1 something, and we're going to find y in a little bit, or it could be down here. See how it's symmetrical? It could be negative 1 and something else. In this case, y is going to be negative, and up here, y is positive. Okay, so this distance, let's do some different colors so we can see. This distance, remember, or not, yeah, this distance is 1, negative 1. This right here is 2. So do you see how, using Pythagorean theorem, we could find this side right here? Let's call it y. So we have 1 squared, because that's the absolute value of the distance, plus y squared is equal to 2 squared. So solving this, y squared is equal to 4 minus 1. Y squared equals 3. Take the square root. So you can see that y is equal to rad 3. So that's right here, square root of 3. If you were to use this ratio, though, where would this be? This is negative square root 3. I'm going down. So this is positive square root 3, this point, and this is negative root 3, that point. So the two options are, we have to find sine of theta in this case is y over r. Well, we can say that y over r would be the square root 3 over 2, or it could be negative rad 3 over 2. All right? The tangent of theta would equal, in this case, we can say it's going to be y over x, so that's root 3 over negative 1, or negative root 3 over negative 1, which would actually give you a positive root 3. This one right here would give you a negative square root of 3. So if the question was more specific and said that the terminal side lies in a specific quadrant, maybe it said quadrant 2, then you wouldn't have to do both cases, but that is not the case in this. So that's how you do this example. Let's look at number 24, cosine theta. Cosine theta is equal to 0. Remember that ratio, once again, is x over r. Well, r is defined, it can't equal 0. So that implies, since r can't equal 0, x must equal 0 to make this statement true. So this puts me up here at 0, y, whatever that is, or 0, y down here. You can choose any point for y, make it easy. So let's say y can equal positive 1, or down here, so we'll just say positive 1, or down here we'll say y can equal negative 1. And you can do your ratios accordingly. So that also implies that the distance r from the origin is 1 unit, either up here or down below. So we'll do the two cases. When x is equal to 0, y is equal to positive 1, and r is equal to positive 1, we have our ratios as the following. Sine of theta is 1 over 1. Tangent of theta is y over x, which is 1 over 0, which is undefined. And cosine of theta was already given. Cosine of theta is equal to 0. On this side, when we have x is equal to 0, so now we're doing this possibility, this point. So x is equal to 0, y can equal negative 1, and r can equal 1. So the sine of theta is equal to negative 1 over r, which is negative 1. Cosine of theta, once again, is still 0, so if you do 0 over r, which is 1, is 0. And the tangent of theta is negative 1 over positive 1, which is negative 1. So the last example I want to show is 32. Tangent of theta equals 1/2. If you look back at the chart, remember tangent of theta is y over x. So not only could tangent theta be positive here, it's greater than 0. Remember down in quadrant 3 you have a negative x value and a negative y value. Two negatives make a positive. Negative over negative equal a positive. So this is also where tangent theta can be greater than 0. So once again, we have two cases. Y over x, that tells me that x is equal to 2, y is equal to 1, and r would equal, well, if you think about, so just suppose a point's here. This is the terminal side. So I'm going over x units, so that's 2 units. I'm going up 1 unit. And what is the hypotenuse? Well, it's 2 squared plus 1 squared equals r squared. That's r, remember. So r squared, or r, is equal to the square root of 5, it looks like. 2 squared is 4, plus 1 is 5. So that's root 5 is our side here. Okay? So that's on the positive. Now, in this case, I could also do theta down here. So I could have negative 2, negative 1, and my r would be positive square root of 5, this distance from the origin, remember? So x equals negative 2, y equals -1, and r is equal to the square root of 5. Okay, so when you do these ratios, and they're asking for sine, cosine, and tangent, on this side, the sine of theta would equal y1 over square root of 5. Cosine of theta is equal to 2 over the square root of 5, and tangent of theta, that was given, but we'll just check it, is y, which is 1 over 2. Okay? Now on the right-hand side, for x equals -2, y equals -1, and r, we have that the sine of theta is equal to, which is -1 over the square root of 5. Cosine of theta is equal to -2 over the square root of 5, and tangent of theta would be -1 over -2, which is equal to 1/2. So you see how you get the same answer in quadrants 1 and 3. Now, in the future, you might see this rationalization of the denominator. So if you wanted to rationalize this, remember, sometimes answers, they change them at this multiplication. Sorry. You just make it bigger if you mess up. So if I multiplied the bottom by square root of 5, do you see that the denominator would give me a 5? But if you do it to the bottom, you have to do it to the top. Notice that root 5 over root 5 is equal to 1, so I'm not changing it. I'm just giving this fraction a makeover. So that's how you rationalize. It would be root 5 over 5 with a negative sign in the front. Okay, this concludes our lesson, but please come and see me if you have any more questions during the week. And remember, CCC Confer session on Tuesday from 2:30 to 3:30.